Hello everyone, welcome back to my YouTube channel. Today I'm going to discussing about tree terminology. After this session, you can take a general idea about these things. What is a tree, root node, leaf node, edge, path, child node, parent node, siblings, subtrees, degree, level, height, and depth. So first let's see what is a tree. In data structures and algorithm, a tree is a hierarchical data structure consisting of nodes where each node has a value and links to a child node. It is a nonlinear data structure used for efficient searching, sorting, and organizing data. So here are some real life example of trees. First one, organizing chart. Second one, file system and the family tree. Now let's see what is a root node. A root node is the topmost node in a hierarchical data structure such as a tree. It is the starting point from which all other nodes descends. The root node has no parents but may have child nodes. Every tree has exactly root node. As example, the CEO in a company hierarchy. Here has some key characteristics of a root node. First one is topmost node. It is the first node in a tree structure. Second one, no parent. Unlike other nodes, the root node does not have parent. Third one, can have children. The root node can have multiple child nodes connected to it. And last one, unique in a tree. A tree can have only one root node. Here some tree structure. So you can see 6 is the starting point of tree. So 6 is the root node. Let's talk about leaf node. A leaf node is a node in a tree data structure that has no child nodes. It is the endpoint of a branch, meaning it does not have further descendants. Leaf nodes are also called external nodes or terminal nodes. As example, individual file in a file system. Here are some key characteristics of leaf nodes. First one, no children. A leaf node does not have any child nodes. Second one, bottommost node. They appear at the lowest level of the tree. Third one, multiple leaf nodes. A tree can have multiple leaf nodes. And the last one, dependent on parent nodes. Leaf node always have at least one parent. So, as you can see, tree, in given tree, the nodes 1, 3, 7 and 9 are leaf nodes. So, let's move to the edges. An edge is connection between two nodes in a graph or tree data structure. It represents relationship or link between the nodes. In a tree with n nodes, there are exactly n minus 1 edges. Example of edges in real life: family connections, roads between cities. So here are some key characteristics of edges. Connect two nodes. An edge always links two nodes. Second one, can be directed or undirected. Some edges have direction while other do not. Third one, carries weight. In weighted graph, an edge can have numerical value representing cost, distance, and etc. If a tree has 7 nodes, then number of edges will be 7 minus 1 is 6, as you can see. Let's see what is a path. A path in a tree is a sequence of nodes connected by edges. It represents way to travel from one node to another node within a tree. Here has types of paths. First one, root to leaf path. A path that starts from the root and its end from the leaf node. Second one, simple path. It means a path where no node appears more than once. The third one, shortest path. The path with the minimum number of edges between two nodes. For example, in a tree, the path from 6 to 7 is 6 to 8 and 8 to 7. So length path is 2 edges. The second one, the path from 2 to 3 is 2 to 3. So length is 1 edges. Next, move to the parent nodes and child nodes. First on parent node. The node which has a branch from it to any other node is called as a parent node. In other words, the node which has one or more children is called as a parent node. In a tree, a parent node can have any number of child nodes. As example, in a company, a manager is a parent node of their employees. So let's see key characteristics of parent node. First one, has at least one child. A parent node must have one or more children. Second one, can be any node except a leaf. It means any node within children is a parent. And the third one, can have parent itself. A parent node may also be a child of another node, except the root node, which has no parent. As example, number 2 is parent of number 1 and 3, and number 8 is parent of number 7 and 9. So let's see child node. A child node is a node in a tree data structure that is directly connected to another node called its parent node. It is a descendant of parent node and can have its own child nodes. As example, in a company, employees are child nodes of their manager. And key characteristics. First one, has a parent. Every child node has one parent. Second one, may have its own children. It means a child node can also be a parent to another nodes. And the last one, leaf nodes are special children. It means if a child node has no further children, it is called a leaf node. And in here, number 7 and 9 is children of number 8, and number 8 is a child node of number 6. Let's move to the siblings. In a tree data structure, siblings are nodes that share the same parent. In other words, siblings are nodes that are at the same level of the hierarchy and are directly connected to some parent node. As example, employees under the same manager. So here are some key characteristics of siblings. First one, same parent. Siblings have the same parent node. Second one, same level. Siblings are the same depth or level in the tree. Last one, can be multiple. Here can be multiple siblings depending on the number of children the parent node has. So as example, here 1 and 3 is siblings because 1 and 3 is child nodes of the number 2, and 7 and 9 is the siblings because 7 and 9 are the child nodes of number 8. Next one, subtree. A subtree is a smaller part of a tree that consists of a node and all its descendants. Every node in a tree can be considered the root of its own subtree. As example, department team within a team. Here has some key characteristics of subtree. First one, root of subtree. Any node in a tree can be the root of its own subtree. Second one, includes descendant. A subtree consists of a node and all its child nodes. Third one, independent structure. A subtree is itself a tree within larger tree. Fourth one is a multiple subtree. A tree can have multiple subtrees, one for each child of a node. Last one, recursive nature. A subtree follows the same structure as a full tree. Here are example of the tree. Here you can see the subtree rooted at 2 includes 2, 1 and 3. And the next subtree is 9 includes with 9. Let's see what is the degree. Degree of a node is the number of child nodes a node has. Degree of a tree is maximum degree of any node in the tree. As example, in a company hierarchy, a manager with 4 direct reports has a degree of 4. Second one, employee who report to no one have a degree 0. So here are some two characteristics of degree. First one, degree of a root node. The degree of a root node is the number of child nodes it has. Second one, degree of leaf nodes. A leaf node has degree of 0 because it has no children or connected edges. In this tree, you can see degree of 6 is 2 because 6 has two number of childs. And as you take number 2, it also has 2 child nodes, so it degree value is 2. If you take number 1 has no any child nodes or connected edges, so it degree is 0. Level. The level of a tree refers to the distance of a node from the root node in terms of the number of edges along the path. The level of node is essentially its depth within the tree. The level count start with number 0 and increment by number 1 at each level or step. As example, in a company hierarchy, the CEO at level 0, the directors or managers are under the CEO are at level 1. The employees reporting to those managers are at level 2. So here are some key characteristics. First one, level of root node. The root node is always at level 0. Level of child nodes. Direct children of the root node are level 1. Third one, level of descendant nodes. Each child increase the level. Fourth one, level in a tree structure. The level of the node is number of edges from the root to that node. And the last one is maximum level of a tree. It means the deepest node level is also called a height of a tree. In here you can see, in this case, the tree has 2 levels. Let's see what is the height. The height of a tree is the number of edges on the longest path from the root node to leaf node. It represents how deep the tree is. Height of a tree is that height of a root node. As example, file directory structure. Here has some key characteristics. First one, height of a leaf node. A leaf node has a height of number 0. Second one, height of a root node. The height of root node is equal to the height of an entire tree. Third one, height calculation. The height of node is 1 plus the maximum height of its child nodes. If a node has no children, its height is 0. The last one is height of a tree with 1 node. If a tree has only 1 node, its height is 0. In this case, 6 has height of 2, 2 has height of 1 and 1 has height of 0. The last topic is the depth. The depth of a tree refers to the distance of node from the root node, measured in terms of the number of edges along the path. As example, the depth of an employee in a company hierarchy is the number of levels between employee and CEO. CEO is a root node. Let's see height was depth. Height is measured from the root to the deepest leaf, and depth is measured from a specific node to the root. So here has some key characteristics. First one, depth of a root node. The root node is always at depth 0 because it has no parents. Second one, depth of child nodes. The depth of node is 1 plus the depth of its parent. Third one, depth calculation. The depth of any node is the number of edges from the root to that node. A leaf node has depth equal to the number of edges from the root to it. The last one is maximum depth. The depth of the tree is the depth of its deepest node. The maximum depth is also called height of a tree. So, in this case, 6 has a depth of 0 because 6 is a root node, and 2 and 8 has a depth of 1, and as a leaf node, 1 has a depth of 2, and it is the height of a tree. So today we discuss about tree terminology. So I think you got basic ideas about topics. So I hope this video helps you to understand tree structure better. Don't forget to subscribe my YouTube channel TechDila. So thank you and see you in the next video.